Hi there, my name's Vince from mymatevince.com, and in this video today is another trying to fix video, and this item's been sent in by Lee, the same guy that sent in the multimeter, the Red Pocket Game Boy, the 3D pen and the camera. So it says here, hi Vince, do you like jigsaw puzzles? Bought this faulty from eBay while on another retro whim. Advertisers no power. I traced power to the main board and spotted one of the capacitors had blown its bottom. I replaced all the capacitors but still no power. I then replaced the voltage regulator. It came to life, sound, then screen, but only lasted 5 seconds. Smell of burning and the regulator was super hot. Replaced the regulator again and the same thing happened. I've now lost patience with it and it was destined for the bin, but then thought you might like the challenge. I've included all the original removed components so you can check I have put the right parts in. Battery lid is not original, was missing. I 3D printed it from a file online. If it's not suitable for a video, just throw it away. If you get it working, happy gaming, Lee. So it is a Grandstand Astro Wars. Now I've had one of these on the channel before. Let's just tip it all out. And that was from one of my friends actually, that and Firefox. But that was just, although I took it apart and stuff, it was just faulty battery terminal. So hopefully this one might be more interesting. Okay, so we've got all the bits and bobs in here. Right, so that must be the voltage regulator that he is talking about. Ooh, now that is the blown capacitor there. Now that doesn't just look like leakage. I wonder if this had reverse polarity on it. You know, the jack. And that is a 3D printed battery cover. Actually, that feels surprisingly strong. Strange thing is, the finish on the inside seems to be better than the finish on the outside. But yeah, it's definitely better than not having anything there at all. Right, okay, so let's have a quick look at the board here. So we've got the batteries go in the back here, 2 terminals here, they go up to a little jack and then they go into this board here. From this board they're connected to this one via a ribbon cable, which looks like it's... Okay, well we definitely got a loose wire there, but that's probably just happened in transit. We've got a little joystick here. Again, is that broken? No, yes, that's broken there as well. Okay, so a little bit of soldering needs to be done. Now, is that the... that looks a bit iffy there, doesn't it? Looks a little bit burnt there, actually. What's that say? 10 times. Oh, no, XO1. Oh, that might be a crystal. I wonder if that's a crystal. So this looks like the voltage regulator that he's talking about. BCE. Base collect. Do you know what? That's that looks like that's a transistor, isn't it? BCE, base collector emitter. Now let's see which one was the one that blew. So it's a 330 microfarad 10 volt, which is this one here. Okay, so let's just quickly trace where the power goes to. So the power goes to the jack, to the board here. Let's follow the 6 volts. We need to double check as well if it's what the center pin is on this one. Does it say anywhere? There you go, negative polarity. See at the bottom there. So I'm almost certain now that somebody's put in something into the jack that's off either higher voltage because it only needs 6, what's it say here, 4 C-size batteries. But if it's 4, you think it's going to be about 6 volts. So yeah, maybe somebody put in a power adapter into here that was more than 6 volts or reverse polarity. So, and I seen that on a games console ages ago. In fact, my first ever trying to fix video, and it blew the capacitor completely. So maybe that's what's happened here, because maybe there's no protection, like diode protection on this. But anyway, look, it says here 6 plus here, or plus 6. So this is the 6 volt one here going up on this side of the ribbon cable. So on that side of the ribbon cable is this one here, and that does go to that capacitor. Can you see from here? It goes to there. So I think that's what's happened. Right, okay. Soldering here looks a bit iffy. This is where the that transistor's been replaced. I'll tell you what, let's get it over to the blue mat. Okay, so I looked up that little transistor, and it's called a power transistor, and it is an NPN. And where has it gone here? So let's just test the old one, make sure it definitely is testing faulty. So if we were to put this into diode test, this side here, let me just double check. The base is this side here. So positive here. Okay, you can see there's a short there and nothing there. And if I was to swap the leads around, again, there's a short there and nothing there. So 100% that is faulty, because it shouldn't be acting like a short in both ways. We should have a read in one way, but then not the other way. So yeah, that's definitely faulty. So now let's go on to, I know this is measuring it in circuit, but let's just see what this is testing in circuit. So the base, this side here, is this side, the B. So positive on there. Okay, and you can see that that is a normal, I don't know what the reading is, like between 0.4 and 0.9 or something like that, but that's normal. Now I'm going between base and emitter, and that's normal. Now let's swap the leads, and we shouldn't have a reading this way. No, and no. Okay, I think that that transistor is okay. So I'll tell you what we'll do, let's do some testing on continuity. So when you hit the leads together, they beep. Let's zoom in for this. Right, first of all, I just want to double check that the middle one is negative on this. So if I was to go to the positive terminal here and the middle pin, we're not getting anything. If I was to go to the negative terminal, we're getting something. And then if I was to go onto the positive and go onto this part here, right, we're not getting anything. Let's go onto the wires on the back. Not getting anything. Right, we're getting it there, but not there. Getting it here, but not here. So that's not going to push power through to the board, is it? That should be joined now when we're on batteries, and then that should break the connection here when we're on when we plug in the DC jack. So there's something wrong there as well. Also, that's very, very, very close. You see that wire there? That's very close to there. Let's just see if there's a short between terminals here. No, there's not. No, but could there be if we did that? Yeah, look at that. Now we've got a short. So yeah, that needs sorting out there as well. That's that wire's gone a little bit straight and it's hitting the central conductor. Right, something doesn't look right with this one here. So we've got to sort that out. We already know that we have to cut back these and solder them on again. But this is the thing I'm slightly worried about. This connection here doesn't look great. So let's go from the positive. So the positive goes to here. It goes round to here, which is that thing there. I'm just going to look up what that is. Right, this is a transformer to drive the VFD display here, the vacuum fluorescent display. So this isn't like your normal LCD display. This is a little vacuum display. So it's nice. And this thing down here, which looks like an ink stain, this confused me when I seen this all those years ago. And this is called a getter, and it's to attract the, I think it's to attract the impurities in here when this is made, so they get drawn into this. It's lovely, isn't it? Right, okay, let's, yeah, so that's that there. Where else does this go to? So that goes into here, so that's providing power into the transformer. And this has got, transformer's got loads of things coming out of it. I suppose feeding the, feeding the display up here on that one, isn't it? Going round. Right, so from here it goes to here. Here to here. Goes around to here. What's this thing here? Oh, we've got a little transistor here. Right, so where do these things go to then? This goes round to here. Okay, that doesn't, that's Right, that's not making contact there. Okay, let's try, and that one looks good. Let's try this one here. Yes, yes. Now this is the iffy one here. So this goes to here. No. Right, let's try that here, here. No. Right. I'm wondering whether or not the original fault was, for example, blown capacitor, and it took out this. Thing is, why did it take out that? Where does this go to? That goes up to here. Transistor. Ah, look, and then that transistor goes up to here. So maybe this transistor's gone as well. Let's see if we can test this. Let's see if we've got any shorts across this transistor here. I don't know which is the base and the emitter and stuff. I don't think we've got any direct shorts anyway, but that's not on dia test. I think maybe the original fault was the capacitor and this transistor here. And I think what's happened is when Lee's taken off this transistor, the board's got slightly damaged here, which happens because if you have it too hot and you use a solder sucker or even wick, it's very easy to lift up, really easy to lift up the pads. I'm wondering then, he's put it back together and he said it worked, then stopped. I'm wondering whether it was making a contact and then maybe when it heated up a little bit it broke the contact, or if it was only just barely hanging on, whether it burnt out. But he did say it got very hot. But I think the first thing I'm going to do here is I think I'm just going to resolder everything. I'm going to have to, I think I'm just going to run wires from here because that looks a bit damaged. This one looks like pretty much perfect. I'm just going to zoom in on here to see why this one's not making a contact. Right, so we can see the break there. There's just a little break here, isn't there? So that could have been it if it was just barely hanging on. There you go, it's gone there. Right, I'm going to run wires from them. From that one and that one. That one looks to be... Okay, that might be a bit iffy there as well. I think I'm going to run wires on all of them. So I'm just going to be using some leftover wire from some Christmas lights. So this should be ample thick enough. So I'm going to be soldering up wires from there to the different points, the nearest solder joint from there. And I'm going to be cutting back these little ribbon cables because these just have normal wires in them. And then I'm going to be unsoldering them and then cutting them back and then reconnecting them up again. I'm just going to be fast forwarding through all of that because it's going to take a while. And you've seen plenty of soldering before. The jack here we're going to have a closer look at because this jack isn't doing what it's doing. But I'm going to resolder that connection there, and then I'm not too sure why it's not working. I don't know, should there be a spring or something in there? Maybe we can prise it open and have a look at it. Mind you, it's kind of riveted on there, isn't it? So that might not be an option. We'll do the soldering up first anyway. So with the ribbon cable, I'm just going to cut the ends off it to make them all level, and then I just need to expose a little bit more of the wires. Right, so I think that's the soldering done. So what I'm going to do now is give everything a nice good clean with IPA. I'm going to go over this loads of times because it's got a load of that conformal coating on and it's just making the whole thing really sticky. I'm just going to wipe it all away. Now look at this, just when I've been wiping away the mess, can you see that we have two joints here that look like they're really bad? That one there, and also this one here, not as bad. But yeah, this one here has barely got any solder on. So I'm just going to resolder them. That would have been from manufacture, those ones. That's a bit better, it's still a bit sticky, but yeah, it's horrible stuff. So if you have a look now, you can see that I've run the wires from here to the other pads. I've resoldered this, and I've just touched up a few of the other solder joints. So now what I'm going to do is get some batteries, pop them in the back, and let's see whether we have 6 volts coming up on these bits here. Does actually work. Yeah. Okay. So we should have 6 volts on here now, but I don't think we are going to have it. So just make sure the batteries are okay. Yeah, 6 volts. Right, so let's see what we got here. Nothing. So now, it'd be fine if we plug in a power jack, because that will just go past there. Because if I was to go to continuity here, and go on the middle pin, that's going to go straight to here. Yeah, and then the outer pin here is going to go to there. But the idea of this is that when you plug in a jack, it disconnects it from the battery. So right now it thinks there's a jack plugged in, but there's not a jack plugged in. So let's pop out the batteries and find out what's going on. Now, embarrassingly, this probably took me about half an hour, maybe even 45 minutes to get to know how this barrel jack works. It's really obvious when you know. The problem is, like everything in life, if you don't know, it's not obvious, and it's only obvious when you know. But to an awful lot of people, they don't know stuff. And when you're in the know, you're in the know. And when you're not in the know, you're not in the know. So now I do fully understand it. And when it comes to other barrel jacks in the future, I will hopefully, because I've got a feeling most of them will take the same principle as this one here, I will understand it. But the reason it took me so long is because I didn't understand it. So, yeah, the bit you're seeing fast forwarding now is just me over and over again, just bending it, trying to put extra pressure on it, trying to work out what's happening. It weren't until I took out the bottom connector completely that it all made full sense, which I will show you right now. Right, let me just show you what's going on here. So it's actually really simple, but really, really hard to fix. I think I'm probably going to have to see if I can buy one of these. So the central conductor, that's fine. That just goes from there straight through the back here. Yeah, that makes sense. So we know that that's going to be working fine. The problem we've got is with these two bits here. Now, it's actually quite simple. The bottom one here is this long pin coming out here, which is normally bent round. And the middle one, which senses whether or not, this one here, senses whether or not the barrel jack is plugged in, is a little shelf right the way in here. Can you see that shelf in there? Yeah. So what should happen is, this end here should be resting on that shelf, putting pressure upwards, and then it makes the contact when the batteries are in. But when you plug the power jack in, it pushes down. When you plug the barrel jack in, it pushes down this metal thing away from the shelf at the back, and then it breaks the contact, which allows you to then just it doesn't put charge back into the battery. The problem is every time I bend this over, it loses its spring, and I can't take it out. I need to take the whole thing out in order to form it properly, so then I can push it back in. But I'm having real trouble. So I'm just going to do this all off camera. I don't think I'm going to be actually able to repair this particular connection here in a reliable way. Okay, so I've managed to get it back together. It's a complete bodge job, but believe it or not, it is actually working. So the middle The bottom one, the middle one's fine. The bottom one snapped because when I had it all out there, just bending it around, there's only thin metal. It just broke. So what I did is I kind of made a joint. I folded it back round on itself like this. So we still had the bottom bit sticking out like this, folded the top bit round like that. And then I bent it into shape when it was out of here. And then I put it in and I just added a little bit of solder into that joint. And amazingly, it does seem to be working. I mean, it looks awful, but it does seem to be doing its job. So there you go, you can see it there now. So watch this. If I go between here and here, you can see that I've got continuity. And now if I plug in the barrel connector like so, and then go between here and here, you can see continuity has now gone. And then if I unplug it and go between here and here, it's now back again. So it does need to be replaced, but I don't know, I mean, it might last. I mean, I did solder this joint up here. You can see a little bit of solder here. I heated it up. I just put the iron on this bit here, and then I put the solder into each edge, and it definitely flowed into it. You can see I burnt the connector a little bit, but it's working. Bodge job, but it's working. Right, so now let's get this soldered back up together, and let's see if we have any life in it. Now let's see if I have 6 volts on the board. Yeah, 6 volts there and 6 volts there. Fantastic. Right, let's now plug this in and see if the 6 volts disappears. Remember, there's nothing connected to this barrel jack. Excellent, you can see there the meter's showing 0. Unplug it. I'm not going to tempt fate, I'm not going to do that too many times. 6 volts, there you go. Right, so I am going to, what am I going to do now? Right, let me put this barrel jack back into my little monitor so I can actually film properly, and then we'll have to short out this thing here and see if this comes to life. Here goes, let's see what's going to happen now. So we have power here, so when I short this power thing here, it should come together with the switch. And it's not. Right, it's not coming together. Alright, well let's measure voltages around the place. So we should have 6 volts here. Oh no, we won't, we'll have it here. Yeah, 6 volts. So that shorts together. So now if I was to I'm gonna have to clamp those together, aren't I? Let me just put a bit of solder on there for the time being. Saying that, that's not going to give me any control if something starts burning out. I wonder if I was just to rest that. Right, 6 volts there. So when I do this here, that should transfer 6 volts to here. Ah, 4.8. Okay, we've got a bit of a drop there, haven't we? 4.8 volts. Yet nothing's happening here. I wonder, is that going to get... Oh god, that is warm. That really is warm. Right. Yeah, that's not right. Okay, yeah, so like Lee said, it's getting very warm. So that's probably where the voltage is going. So something is being dragged down to ground somewhere, isn't it? Right, let's take out the batteries. Problem is I haven't got a spare transistor at the moment. I've got other transistors, but not those ones. I think these ones go up to 3 amp. The ones I have are just 1 amp. So I presume that would probably burn out pretty quick. Right, so we have 6 volts on this one here, I presume. So from here it should go all the way from here. It should go to here. Goes up to here, around, and into this transistor. Right. We know the second one is ground, so let's just check. See if any of the capacitors are shorted. No, they're not. Yeah, that transistor does go around to it, because look, it goes from here, around here, and up to this one here. I'm going to unsolder this transistor. Right, this says MLC945R. And it has got ECB written down here, so maybe I could just test it going by that. So let's have a look. Let's put this to diode test. Right, I'm going to put the red probe. Obviously, I don't know whether this is a PNP or NPN, but let's go here and here. Okay, that's giving me a reading low though. Let's go between collector and emitter. Right, that's giving me a normal reading there. But that doesn't look right there, does it? Right, let's swap them over. Okay, and it's giving me the same reading there, so that's not right. But can you see here, so between base and emitter is correct. Because look, we're getting a, so this is going to be a NPN. Yeah, that's right, but there's a problem between the base and the collector. Yep, I think that might be faulty. Maybe there's other things faulty as well. I'm going to see what this is and see if because I do have a transistor pack, see if there's a replacement in that. I'm going to look online and see exactly what this one is. I had a look up online and it is it's down as a C945, I think, and it's MPN. It's just a standard transistor. So one of the ones that is compatible is this one here, the BC547B. And you can see general purpose NPN. The only problem is obviously the base emitter and collector are in different positions, so I'm going to have to bend them to suit. Now, yeah, so basically when I've had a look at the back here, sorry, just to show you just on diode test, so this one here has the base in the middle, so positive in the middle. And if you have a look here, this is the good one. If I go between this side here, which is the emitter, you can see it's giving me a nice reading. And the same sort of reading there on the collector, and if I swap it round, it gives me no reading this side and no reading this side. So right now that transistor is okay, which is the opposite of which this one is doing here. So base here, can you see that we're getting a reading on the collector both way round. So now with this, if you have a look at the back, we know that if we put this in here like so, that the base is on the bottom one here. So what happens is when voltage is applied to the bottom one here, then it will provide put current through from the collector to the emitter. So the collector is the middle one, so collector to emitter. So look, basically the collector, can you see, it's taking this voltage from the 6-volt rail. So this is like the first transistor that turns it on. Can you see here? It goes to here, and then it will connect this one up and it will go to this one here, which is the base of the one that Lee replaced. The base is up this side here. So then when this gets voltage here, it will turn on these two here, allow current to go from the collector to the emitter and then go on to this one up here. Right, let's get this transistor in the correct way. So we know that that one there is the emitter. So on this one, it has to be that way round. So I'm going to be putting it in kind of back to front. So that's going to be the emitter. And then the middle one's got to be the collector, which is going to be this one here. So we're going to have to really bend these around, aren't we? I think I'm just going to leave them really long so I can bend them around the place. Right, so we have the base go into this one here, which is correct. We've got the collector, which is the one on this side here, go into the middle, which is correct. and the emitter go into that one there. That's all correct. Right, let's solder that up. Let's pop the batteries in and see if it does anything different. Here goes. Not so sure this is going to make any difference, you know. Here we go. Right, it made a bit of noise there. It made a bit of noise. Has that gone hot again? No, let's try that again. Screen's not lighting up though, is it? It's getting hot again. Ah, it's getting hot again. What else could be causing it? And the capacitors are all the correct way round. Here we go, here we go. Yes, the lights are there. You just can't see it because they're so bright. That's very warm though, very warm. But maybe it just gets warm. Let me turn the lights off so you can see it. I think this thing's not making a great connection here either. But watch this now. You're still not going to be able to see it probably. There you go, look. Thing is, this thing is getting warm. I wonder would it be worth putting a heat sink on the back of it. I think I'm going to stick a heat sink on the back of that. Apologies, I wasn't filming that bit, but there you go. Thermal glue. I put a blob on here, and then these are the heat sinks here. So now, just to reinforce that, let's put some glue gun all around here. I've just lifted it up because I don't want that post. I want that hole kept free because one of these posts must be going through it. So while I'm here, I'm going to do glue all around here to keep that in place. I'm going to glue these wires here, and I'm also going to put some glue on these ribbon cable things down here. People sometimes say in the comment, why do I do this? It's because when you use the glue gun itself, of course it gets hot enough to melt, but this really gets it hot. And then when you get it really, really, really hot, it's supposed to give a better bond. And I'm just going to let that dry, and then I have to start putting it all back together. Luckily it just about fits, but it is quite tight. Hoping it will be alright though. These buttons all look okay. You can see that they put different colours on, purely to change the colour off the screen to make the game look more interesting. Here goes. Excellent. But there's nothing on the screen. Oh, come on. I was sure that was going to be it. So, what's going on? There's no brightness to it. Yeah, there's no... Right, so it looks like the main chip's working because the game is being played. It's just I can't see what's happening. Now it's gone off. Right, let's take it apart again. So is it to do with that? Is it to do with that power transistor? Maybe I need to take it out of circuit and test it. Maybe it is testing faulty and it's not allowing through the correct voltage, which is not allowing the VFD, the display, to light up. Okay, so I've just taken the cover off and I've unsoldered the power transistor there because that's the thing which is getting warm. And when I put it in the component tester here, it is coming up as an NPN transistor, base emitter collector. So that looks to be okay. And when I go on the meter here, positive to the base, and here you can see there normal reading, and on the emitter normal reading. Swap the leads over, see, nothing and nothing. So I would say that that is testing okay, but this is what I'm thinking. We know that it is working, the game is playing, but it's too dim to see. So I think what's happening is, I think the voltage going through here, some of it's, well, a lot of it's being converted into heat because this is really getting very hot. And I'm thinking, I don't think it's designed to get that hot. Otherwise, this would have been built with a big heat sink on it, and this would have been like bolted down onto it to dissipate the heat away. So I'm thinking that if this is supposed to be providing X amount of volts to whatever it needs to provide X amount of volts to, I'm thinking that maybe it's providing 1 or 2 volts less because it's converting that into heat. So what I'm going to do is, I haven't got any of these, but I've had a look on eBay. You can get 5 of them for £5.50, so they're not exactly expensive, they're only 50p each. But what I have got is, I've got in my little transistor set here, I have got some power NPNs. Now, they only go up to 1 amp, and when I looked at this one, I think this was 3 amp. So it's not going to be suitable, but it might give us a bit of a game, and then it will tell me whether or not that is faulty. Because if this is also doing the same thing, then I'm thinking that that's probably not going to be the problem. So I'm looking for BD139. BD139, got it there. Right, so let me just double check the orientation of this. So it's like that, and we got emitter collector base. So this one here is the emitter, so it needs to go in that way round there. Right, I'm just going to solder it up, just roughly. I'm just going to tap the wires onto the end of it, and we'll see what's happening with it. Right, they're only just barely hanging on, but they should be okay to test. Right, here goes now. My lights are on full. Let's turn them off again. Right, so when I put this on here, let's see what happens now. That might end up burning up. That sounds louder. Oh, there we go. Oh, there's no comparison there. Remember before I was doing that? That's much brighter. Okay, 100% then. The fault was... So the original fault was blown capacitor, blown little transistor, blown big transistor. And then Lee swapped over the capacitor and the big transistor, but not the little one here. And that's the reason it kept, getting hot and burning up. There we go, I'm happy with that. Right, what I'm going to do is I'm going to order up some of those transistors from eBay. So I've ordered up 5 of them from eBay for £2.45, so just under 50p each, which is not too bad, is it? So I'm just to finish up the video, I'm just gonna put this back together and we'll end on a bit of gameplay, and then in about 4 or 5 days time, when the proper power transistors arrive, I'll pop one of those in my own time. You don't need to see me film that because you've seen me messing around with that power transistor enough in this video here. So yeah, let's get this back together. Right, it's back together now. Got quite a bit of dirt off it. It was around the grooves and stuff. There was a lot of dirt, and I've cleaned inside the screen and everything as well. Right, what I'm going to try and do is I want to see if this is going to work. This is like a paint pen, but I think it's run out. Nah, that's gone. I just wanted to colour in these bits down here because you can see it's worn where it says power and fire and stuff like that. Let's see what else I've got. Right, I've got a silver one here. Maybe silver will look okay. Yeah, maybe silver will look okay. Let's give it a go. That's going to look just fine. Do you know what? That deserves to be zoomed in on. Right, while I'm doing this, I didn't shout out that My Mate Vince Massive, did I? Naughty me. So, oh, I've gone a little bit inside that one there. Ah, that's not quite as nice now as I wanted it to be. Let's see if I can wipe it away while it's still wet. Okay, so you can see now it's worn away completely, so I'm just going to tap this really gently across the top and hopefully it will just sit on it. So the My Mate Vince Massive this month is Saturnine Cinema. Got to really concentrate now. Operational 117. KitDigital.com. Kip Hakes. Max Rokotansky. Jaw Media, Will Michaelis, and Having Fun Repairs. So, as always, massive thanks to... That looks okay, doesn't it? Not brilliant, but not bad. Massive thanks to the My Mate Vince Massive and also all the other Patreons as well. Let's do this one here. I'm going to let that dry, and then if there's any sort of dodgy bits, I can just scrape them when they're dry. But I think it definitely looks better than it was before because it was hard to read it before. Okay, so here we have it here, and it's come out okay. It's not, remember, it's from I think this is like early 1980s. There was a thing at the bottom saying Japan 1981. So is it 1981? Yeah, there you go. So it's got a lot of age to it. But obviously it's far from perfect, but it appears to be working fine. So when the power transistor arrives, I think it will have many, many more years life left in it. So let's turn it on. I'm going to zoom in a bit onto the screen so you can see. Now I'm just going to be playing through the viewfinder, so it might be a little bit difficult. Let's just do the lowest level. Is that going to go back up or not? Is that going to just hang around there? There, gone. It's got a lovely screen on it. There's something that looks nice about those vacuum displays. Am I going to do the whole level without dying? No. One more. Oh, another one. There we go. Excellent. Right, okay, let's turn that off. 780 points. So it really does look nice. I don't know if that's coming across in the camera, but it's nice and bright. Nice bright display. So that is it. An interesting repair. It needed quite a lot of work. There was a lot of repair work going on with the traces and stuff. So it looks like it was the capacitor. small transistor, big transistor, and also this barrel jack here as well. If you were playing it with batteries, if you had the adapter plugged in, you wouldn't have even known that that was faulty. So it's far from perfect, but considering it's made in 1981, I think it looks pretty good. So massive big thanks to Lee for sending it out to me. And yeah, hopefully it will make for an interesting video. If you enjoyed it, give it a thumbs up and subscribe for more videos. Take care, everyone. See you soon. Bye now.